Hi everyone! Today we're going to study prime and composite numbers. Let us begin by defining some terms. The first is multiple of a number. One number A is a multiple of another number B if there is a positive integer C for which A equals B times C. Example, 35 is a multiple of 7 because 35 equals 7 times 5. Next term, A divides B. One number A divides another number B if there is a positive integer C for which B equals A times C. In other words, B is a multiple of A. Example, 7 divides 35 because 35 equals 7 times 5. We also say B is divisible by A, and we write this symbol A/B, and this symbol is read as A divides B. We also call a factor or divisor of B. Now we go to factorization of a number. A factorization of a number A is a way of writing A as a product of smaller numbers. Example, 5 times 6 times 8 is a factorization of 240. Now let us define prime number. A number P is prime if it is greater than 1 and its only factors are 1 and itself. Examples, 2, 3, 5, 7, 11, and so on. We can see here that the number 2 is the smallest prime number. Also, there are infinite number of prime numbers. A proof that there are infinitely many prime numbers appeared in Euclid's Elements more than 2,000 years ago. Let us define composite number. A number is composite if it is greater than 1 and not prime. That means it has factors other than 1 and itself. Examples, 4, 6, 8, 9, 10, and so on. We can see here that the number 4 is the smallest composite number. Another truth is there are infinite number of composite numbers. Let us go to prime factorization. A prime factorization of a number is a way of writing it as a product of prime numbers. Example, the 240 equals 2 times 2 times 2 times 2 times 3 times 5. In case of repetition of factors, we're going to write it in exponential form. We can have like this, 2 raised to 4 times 3 times 5. The fundamental theorem of arithmetic states that every number has a unique prime factorization, subject to rearrangement of the prime factors. I hope you learned something from this video. See you again next time. Hi everyone. Today we're going to study factoring. Specifically, this is factor the greatest common factor, GCF, from a polynomial. First, let us define greatest common factor. The greatest common factor, or GCF, of two or more expressions is the largest expression that is a factor of all the expressions. How to find the greatest common factor? We're going to follow some steps. Step 1. Factor each coefficient into primes. Write all variables with exponents in expanded form. Step 2. List all factors matching common factors in a column. In each column, encircle the common factors. Step 3. Bring down the common factors that all expressions share. Step 4. Multiply the factors. Let's have an example. Find the GCF, or greatest common factor, of the three terms. 21x cubed, the second is 9x squared, the third term is 15x. In step 1, let us factor each coefficient into primes. We write all variables with exponents in expanded form. So the 21x cubed is now factored out into 3 times 7. That is the prime factors of 21. And for the x cubed, we are going to write the x here 3 times. For the 9x squared, this is equal to 3 times 3 times x times x. For the 15x, this is equal to 3 times 5 times x. Step 2. List all factors matching common factors in a column. So the factors are now written like this. For the common factor 3, it is written in one column. There is also another common factor of x written in another column. It says in each column, encircle the common factors. So we encircle the 3, the common factor 3, and also the common factor x. Step 3. Bring down the common factors that all expressions share. So the 3 is brought down here, also the x. And then the step 4, we will multiply the factors. So the greatest common factor equals 3x. Let us go to factoring. What is factoring, by the way? Splitting a product into factors is called factoring. Example, find the factors of 6. It is showing here that the factors of 6 are 2 and 3. We know that there are other factors like 6 times 1 for this number 6. However, for this topic of factoring, we will only consider prime factors. Let us note that prime numbers are integers greater than 1 whose only factors are 1 and itself. Examples are 2, 3, 5, 7, 11, 13, and so on. Let us discuss now factoring the greatest common factor from a polynomial. We're going to follow some steps. The step 1 says, find the GCF, or the greatest common factor of all the terms of the polynomial. Step 2, rewrite each term as a product using the GCF. Step 3, use the reverse distributive property to factor the expression. Step 4, check by multiplying the factors. Let's have example 1. Factor the trinomial 6x cubed minus 9x squared plus 12x. Our step 1 says, find the GCF of all the terms of the polynomial. In here, the GCF is 3x. Looking at the numbers 6, 9, and 12, the greatest common factor of these three numbers is 3. For the variables x cubed, x squared, and the x, the greatest common factor is x. So the GCF of this trinomial is 3x. Step 2, let us rewrite each term as a product using the GCF. It means we're going to split each term. Look at the first term. The 6x cubed is split into two factors in such a way that one factor should be the GCF. So the 6x cubed is now factored out into 3x and 2x squared. The second term, negative 9x squared, is now factored out into negative 3x, the GCF, times the 3x. For the 12x, the factors are the GCF 3x and the number 4. For step 3, use the reverse distributive property to factor the expression. It means to say we're going to remove first the GCF from the three terms. So see, the GCF is now outside, and then on the second factor, we're going to collect all terms that will remain for each term here after removing the GCF. Look at the first term here. After removing the GCF, the 2x squared remains, so it is written here 2x squared. For the second term, after removing the GCF, only the 3x is coming, so this is minus 3x. And then plus, for the third term, after removing the GCF, only the number 4 remains, so we will copy here 4. Step 4, let us check our answer by multiplying the factors. We should go back to the original problem after the multiplication. So the 3x multiplied by the 2x squared, I will get that 6x cubed. And then the 3x multiplied to negative 3x, the answer is negative 9x squared. And then 3x times 4 is positive 12x. So we are sure that this is correct, and this is our final answer. Let's have the second example. In here, there are two big groups. It is a difference of binomial. Look at this first group here. It is a product of 3y times the quantity y plus 7, and then minus. The second group is 4 times the quantity y plus 7. Let us go to our step 1. Find the GCF of all the terms of the polynomial. So our GCF is this y plus 7. That is the common in the first group and in the second group. So I wrote here the GCF, that same y plus 7. Step 2. Rewrite each term as a product using the GCF. In this problem, it is already in the form of a product in such a way that one of the factor is the GCF. So we just copy that same problem. In step 3, use the reverse distributive property to factor the expression. So we're going to remove first the GCF. So removing the GCF here, we expect two terms in the second factor. In the first blank here, I'm going to write the remaining term after removing the GCF. So looking at this first group, I can see here that 3y will remain after I remove the GCF. So I will write the 3y. And then plus. For the second blank, I'm going to write here the remaining term after removing the GCF. So that is the negative 4. So negative 4 will come down here. So this is plus and minus. I will simplify this into negative 4. And step 4, let us check by multiplying the factors. So we want to multiply these factors and hoping that we will get back the original problem. So the first group is this 3y times the GCF. So this is our 3y. If I multiply by the first group or the GCF, I will get the first group here. And then this negative 4 multiplied by the GCF here, I will get the second group, the negative 4 times the quantity y plus 7. So now I am sure that this answer or these factors are correct, and this is our final answer. Thank you for watching. See you again next time. Everyone, today we're going to study factoring. This time we're going to factor by grouping. How to factor by grouping? We're going to follow these 4 general steps. In step 1, we're going to group terms with common factors. Step 2, we will factor out the common factor in each group. Step 3, factor the common factor from the expression. Step 4, check by multiplying the factors. Let us have example 1. Let's factor out these 4 terms, xy plus y plus 2x plus 2. In step 1, we're going to group terms with common factors. So I'm going to group the first 2 terms, xy plus y, and the last 2 terms, 2x plus 2. In step 2, factor out the common factor in each group. In the first group, the variable y is common, so I'm going to factor it out. So y comes out. What remains inside is the x plus 1. For checking, I'm going to multiply this y to this x, so I will get back the xy, and then y times 1 is y. So I'm sure that this is a correct factors for the first group. In the second group, the common is the number 2. So I'm going to bring out that number 2, and what remains inside is the x plus 1. So checking again, 2 times x is 2x, 2 times 1 is 2. So I'm sure that this is a correct factors for the second group. In step 3, factor the common factor from the expression. We have now here two big groups. For each group, the common factor is the binomial x plus 1. So I'm going to bring out that common factor outside. So it is now x plus 1. Since we have two big groups, the second factor should be a binomial also. So I'm going to collect all the terms that will remain after removing the common factor from each group. So in here, it is y, and then plus the 2. In step 4, let us multiply the factors to check if our answer or if the factors are correct. So x multiplied by y, I will get that xy. X times 2, I will have this 2x. And then 1 times y, will get back that y. And 1 times 2 is 2. So these factors are the correct answer. Let us have example 2. 2x cubed minus x squared minus 10x plus 5. Step 1. Group terms with common factors. So I'm going to group the first two terms and group the last two terms. But you see here, our third term is negative. So while putting the grouping symbol, I should write here the plus and then put the last two terms in the grouping symbol. In step 2, factor out the common factor in each group. The common is the x squared. So I'm going to pull out the x squared. So what remains will be 2x minus 1. In the second group, the common is 5. But I should write negative 5 so that later the binomial here will come to be on the same value with the 2x minus 1 of the first group. So if I pull out the negative 5, what remains here is the 2x minus 1. Before going further, I must check myself if the factors are correct. The negative 5 multiplied by 2x, I will get the negative 10x back. The negative 5 times negative 1 is positive 5. So these factors are correct for the second group. And then for step 3, we will factor the common from the expression. So from the two big groups, the common factor is that binomial 2x minus 1. So I'm going to pull it out. So 2x minus 1 is now here. And for the second factor, I put two blanks because since I have binomials in here, I should have a binomial also in the second factor down here. And then to collect the remaining terms after removing the common factor from the group 1 here, x squared I should copy down here. and for the second group, the negative 5. So for step 4, I'm going to check by multiplying the factors. So the 2x times x squared, the answer is the 2x cubed. 2x times negative 5, I will get the negative 10x. Then negative 1 times x squared, it is negative x squared. Negative 1 times negative 5 is positive 5. So we are now sure that our answer is correct. Let us have example 3. Factor out 2x minus 9y plus 18 minus xy. So let us group terms with common factors. If I group the 2x minus 9y, there is no common between these two terms. Also, the 18 minus xy, if I group these two, there is no common factors for these last two terms. So what I'm going to do is to rearrange the terms. I can put the 2x on the last part. So it's now negative 9y plus 18 minus xy plus 2x. And then from here, I can see now that there is a common factor in the first two terms. Also, there is common in the last two terms. So it's now the quantity negative 9y plus 18 plus. So again, I see here that the third term is negative xy. So I must be careful. I should put here the plus and put the grouping symbol for the negative xy plus 2x. And step 2, factor out the common factor. In the first group, the common factor is 9. But I want this variable y to be positive, so I should pull out negative 9. And if I do that, the remaining terms inside here should be y minus 2. Now to check myself, the negative 9, if I multiply it by y, I will get back the negative 9y. The negative 9 times the negative 2 equals positive 18. So I'm sure that these factors are correct for the first group. Now for the second group, I want that y to be positive also, so I should factor out a negative x. So what remains here now is positive y and then negative 2. So let us check again if the factors are correct. I'm going to multiply negative x by y. It will be negative xy. The negative x times negative 2 will be positive 2x. So I'm sure now that these factors are correct for the second group. And for step 3, let us factor the common factor from the expression. So the common is the y minus 2. It is now down here. And for the second factor here should be a binomial. I will simply collect the terms that will remain after removing the common factor. For the first group, the negative 9 will come here. For the second group, the negative x will remain, and I should copy that down here. And for the step 4, I should multiply the factors to check if it is correct. So y times negative 9, I will get the negative 9y. Then y times negative x, here is the negative xy. Negative 2 times negative 9, I will have this positive 18. Negative 2 times negative x will be positive 2x. So now I am sure that my factors here are correct. And this is our final answer. Let us have example 4. Factor out x squared minus 6x plus 9 minus y squared. Step 1. Group terms with common factors. If I group the first two terms, I can see that there is common between them, and that is x. However, if I'm going to group the last two terms, there is no common for these two. So this is a special case. It is possible that I can group the first three terms. So x squared minus 6x plus y is now taken as one group, and then the negative y squared will be alone. And then this trinomial, I can factor it out into the square of difference of two terms. Then I will just copy the negative y squared here. In step 2, I'm going to factor out using the special product difference of two squares, and this is the formula. When we have a squared minus b squared, the answer will be the binomial a plus b times the a minus b. In this case, the x minus 3 is considered to be the a, and the y is the b. So in applying this formula, it will be like this. So the a, the x minus 3, I will copy here. Then first I'm going to put the plus sign, and then the y. And then multiplied by the quantity x minus 3. This is the a again. And then this time should be minus, and the y. And then I'm going to simply remove the grouping symbol inside the square brackets. So the parenthesis inside is now removed. So these are the factors. So step 3, we're going to check by multiplying the factors if these are correct. So if I'm going to take one term each from this group and to multiply to the other group, this will be the product. So x times x will be x squared, x times negative 3 is negative 3x, x times negative y is negative xy. Next is negative 3 times x is negative 3x, negative 3 times negative 3 is positive 9, negative 3 times negative y is positive 3y. Now for the y, times x is positive xy, then y times negative 3 equals negative 3y, and y times negative y equals negative y squared. And from here, let us see some terms that we can combine or cancel. This negative xy, there is a positive xy down here that we can cancel both of them. Also look at the positive 3y. There is a negative 3y in here, so both terms are cancelled. And then we will collect what will remain, the x squared. Then we have this negative 3x and negative 3x. Combining them, we'll get the negative 6x. We will copy the 9 and the negative y squared down here. So you see, the final answer here equals our original problem. So it means this trinomial and another trinomial here is our final answer. I hope you learned something from this video. See you again next time. Today we're going to study factoring, and we are going to factor perfect square trinomials of this form: x squared plus or minus 2xy plus y squared. First, let us review our special product, the square of the binomial x plus y. And the answer is a trinomial x squared plus 2xy plus y squared. Also, if we have the square of x minus y, the answer is a trinomial x squared minus 2xy plus y squared. This trinomial and this trinomial are called perfect square trinomials because both of them comes from the square of binomials. For today's lesson, we are going to have the reverse process. The problem will come to you as this product, and you will be required to provide factors, which is the square of binomial, either of this form or this form. How to factor perfect square trinomials? We are going to follow these 3 steps. Step 1, check if the trinomial fit the pattern of the perfect square trinomials, either this form x squared plus 2xy plus y squared, or this form x squared minus 2xy plus y squared. In step 2, write the square of the binomial. And step 3, check by multiplying the factors. Let us have example 1. Factor the trinomial 25x squared plus 20x plus 4. Let us check if this trinomial is a perfect square trinomial. First, our 25x squared and the number 4, we can rewrite it as the square of some terms. So the 25x squared is now the square of 5x, and the number 4 is 2 squared. For the middle term 20x, what we will do, first, let us write the 5x in here and the number 2, and these are the bases of the first and the third terms respectively. And then we will multiply by 2. And this number 2 is always constant. When we multiply these 3 factors here, we are hoping that the answer will be the middle term. So 2 times 5x times 2 will give us that positive 20x. So it means to say this given trinomial is a perfect square trinomial. We can now proceed to our step 2, write the square of the binomial, and that will be our answer. So to write our answer, we're going to put 5x as the first term here, and that 5x is the base of the first term, and then plus this positive sign comes from the sign of the middle term, and the number 2, and this number 2 is the base of the third term. And then we will not forget the square outside. So this is our answer, the square of 5x plus 2. Now for the step 3, we're going to check our answer if it is correct. We are going to expand and hope that we will get back our original problem up here. So when we expand a binomial, it will follow this pattern here. So the 5x square, it will give me the 25x square, and that is the first term of the trinomial. If I square 2, that is equal to 4, and that is the third term of the trinomial. Now I will multiply 5x times 2 and times 2, and that is equal to 20x. So the square of 5x plus 2 is our final answer. Let us go to example 2. Factor the trinomial 16x squared minus 8xy plus y squared. I wrote my steps here. So first, I'm going to rewrite the 16x squared into the square of 4x and the y squared to be the square of y. For the middle term, first I will write the minus sign, and then the 4x and the y are written in the middle, and then times 2, and that is a constant. And I will hope that if I multiply 2 by 4x and by y, it will give me that 8xy. And it is. So it means to say this trinomial is a perfect square trinomial. So the pattern is satisfied. I can now go to step 2. I will now write my answer. And my answer, or my factors, is the square of the binomial. So I will collect the 4x. I will put it here as the first term of the binomial, and then minus. The sign comes from the sign of the middle term, and the second term here is the y, which is the base of the third term. Of course, I will not forget the square outside. So this is my answer, the square of 4x minus y. Going to step 3, I will check my answer if it is correct by multiplying the factors. Or I can say that I will expand my binomial. If I do that, it will come to this pattern. So if I square 4x, it will give me 16x squared, and that will be the first term of the trinomial up here. If I square negative y, it is equal to y squared positive, and that is the third term of the trinomial. Now, I will multiply 4x by negative y and times 2. That is equal to negative 8xy. So, my answer, square of 4x minus y, is correct. And that is my final answer. Let's have example 3. Factor the trinomial 100x squared y minus 80xy plus 16y. I can see here that the first term and the last term are not perfect squares. So I can say that this is not a perfect square trinomial. However, I can see that there is a greatest common factor among the three terms, and that GCF is 4y. So I will factor out the GCF, and for the first term, when I remove the GCF, what remains is the 25x squared. For the second term, what remains is the negative 20x. For the third term, what remains is 4. So it means to say, I have now a new problem here. 4y times a trinomial 25x squared minus 20x plus 4. Now, I will check if this new trinomial is a perfect square trinomial. I will rewrite 25x squared into the square of 5x and that 4 to be the 2 square. In the middle term, first I will copy the sign, the negative. Then I will take this 5x right here. I will take this 2, put it here, and then times 2. If I multiply the 2 times 5x times 2, this will be equal to the negative 20x. So it means to say, this is a perfect square trinomial. Of course, I will not forget my 4y to be copied down here. So I will now go to step 2 to write my answer, to write the square of the binomial. First, I will copy the 4y, and then for the binomial, it will be the 5x as the first term, then minus, the sign comes from the sign of the middle term, and then the second term is the number 2, which is the base of the third term. Again, I will not forget the power 2. So this is my answer. 4y times the binomial, or the square of the binomial, 5x minus 2. Now, for step 3, I will check if my answer is correct. First, I'm going to expand the 5x minus 2 all squared. So the 5x squared is equal to the 25x squared. It is written here. If I square negative 2, it will be positive 4. I'm going to multiply 5x times negative 2 times 2. It will give me the negative 20x. And the 4y here, I can write it there and then start to multiply the 4y to each term of the trinomial. And it will give me this original trinomial 100x squared y minus 80xy plus 16y. So I was able to confirm that my answer here is correct. And this is my final answer. Example 4. Factorize 36x squared minus 84xy plus 49y squared. We're going to check if this trinomial fit the pattern x squared minus 2xy plus y squared. First is, we're going to show that the first and third term are squares of some terms. We will rewrite the trinomial and it becomes like this. The 36x squared we can write as square of 6x, while the 49y squared we can write as the square of 7y. Next is, we're going to multiply the bases of first and third term times 2 if it equals the second term. Let us rewrite the trinomial down here. So the base of the first term is 6x, we write it here. The base of the third term is 7y, and it is here, then times 2. Now, we're going to simplify 2 times 6x and 7y, if it equals 84xy. And the answer is yes. If pattern is satisfied, we will now write our factors, and that is the base of first term minus the base of third term, that is squared. So 6x, this is the base of the first term. Then minus the base of the third term is 7y. And then we square. This is now the final answer. Today we're going to do factoring, and we will factor difference of two squares, and this is the form x squared minus y squared. Let us make a review for special product. When we multiply x plus y times x minus y, the answer is a binomial x squared minus y squared. The factors are called conjugates. It means the conjugate of x plus y is the x minus y, and vice versa. While the product, we call this difference of two squares. For today's lesson, we are going to do the reverse process. The problem will come to you as this product, and then you are required to give the factors of this form. How to factor difference of two squares? In step 1, rewrite the two terms as squares of some terms. Step 2, write the factors following the pattern. The x squared minus y squared equals the binomial x plus y times x minus y. Let us have example 1. Factor the binomial x squared minus 9. For step 1, we will rewrite the two terms as squares of some terms. So the x squared is now written as the square of x, and then minus the 9 is now 3 squared. For step 2, we're going to follow this pattern. It means we expect two binomials in our answer. But take note that the signs must be different. One is positive, the other is negative. We're going to put x on the first blank of the binomials. And then the 3 will be the second term of each of the binomial. So we see here we have the x plus 3 times the x minus 3. So this is our answer. Let us have example 2. Factor 64y squared minus 1. Again, we are going to rewrite these two terms into squares of some terms. The 64y squared can be written as the square of 8y, and then minus the 1, we can write it also as the square of 1. And then for our answer, there will be two binomials. In the first term, it will be 8y, also 8y in the first term of the second binomial. And for the signs, it must be opposite. One is minus, the other is plus. In our answer here, the negative comes first, followed by positive. And it doesn't matter as long as the signs are different. Now for the second term, we copy that 1. So it's now placed here and also in here. So our answer is the binomial 8y minus 1 times 8y plus 1. This is our final answer. Let us consider example 3. Factor the binomial 48x raised to 4 y square minus 75 y square. The terms are not perfect squares. We can see here that the variables are perfect squares. However, the coefficients are not. Therefore, these two terms are not perfect squares. But remember, we can check for greatest common factor of each term. I found out that the GCF is 3y squared. So if I pull out that greatest common factor, this first term here will become 16x raised to 4, while the 75y squared will be 25. Of course, the negative sign we will just copy here. So for our problem here now, we have monomial times binomial. And then we will check if this binomial here have terms which are perfect squares. The 16x raised to 4, we can write this as the square of 4x squared and then minus. We know that 25 is a perfect square number, so that is 5 squared. And then we will just copy that 3y squared down here. And then we will have the step 2. For step 2, we are now expecting two binomials here. The first term will be the 4x squared. It's now here and also here. And then for the signs, we will have the plus and minus. And for the second term of the binomials respectively, it will be this number 5. It's now here and also here. So our final answer is this 3y squared times the binomial 4x squared plus 5 times the binomial 4x squared minus 5. And this is our final answer. I hope you learned something from this video. See you again next time. Hi everyone. Today we're going to factor trinomial of this form, x squared plus bx plus c. First, let us review multiplying two binomials. In here I have x plus m times x plus n. So we know how to multiply this. I'm going to get the x from the first group and multiply to all the terms of the other binomial. So x times x is x squared, x times n is positive nx. The next is the m to be multiplied to the other members of the other group. So m times x is mx, m times n is mn. And then I can see that the two terms in the middle has a common factor of x. So I put the common factor x outside. So the other factor will be n plus m. Or since our last term here is mn, I want to interchange the n and the m, and there will be no issue on that. So here it is now m plus n multiplied by the quantity x. So when we multiply this x plus m and the x plus n, this is our answer. So for today's topic, that we're going to factor trinomial in the form x squared plus bx plus c, and to compare with our review multiplication on top, I can say that the b here is equal to that m plus n, and the c, or the constant, is equal to that product m times n. And then later, what we want to get are factors of this form, x plus m times x plus n. Now, we will learn how to factor a trinomial of the form x squared plus bx plus c. We're going to follow some steps. Step 1. Write the factors as two binomials with first terms x, just like this. Step 2. We're going to find two numbers m and n. And this m and n will be those terms that we're going to write on the blanks in the step 1. But there are two conditions for this m and n. This is the first condition. If we multiply the m and the n, it should be equal to the c. And this c is the constant of our trinomial. The next condition is, if we add the m and n, so that is m plus n, it must be equal to b. And this b here is the coefficient of the x in the middle term of the trinomial. So once we comply the step 2, we will go now to step 3. We will use m and n as the last terms of the factors. So it will be like this now, x plus m multiplied by x plus n. And step 4, we're going to check our answers. We will check by multiplying the factors, and it must come back to its original problem or the original trinomial. Let us have some examples. Example 1. Factor the trinomial x squared plus 13x plus 30. Step 1 says, let us write the factors as two binomials with first terms x. So I wrote like this, the x plus blank and then x plus blank. In step 2, let us find two numbers m and n such that the product of these two numbers is equal to c, and the sum of these two numbers is equal to b. Here is the list of factors of 30. The first is 1 and 30. The second is 2 and 15. Third, 3 and 10. Fourth, 5 and 6. Now on this column, we are going to add the factors. 1 plus 30 is 31. 2 plus 15 is 17. 3 plus 10 is 13. 5 plus 6 equals 11. As we can see here, this 13 here matches our B. It means to say the factors 3 and 10 is what we want for the M and N. So step 3, we are going to use the M and N as the last terms of the factors. So from here, the 3 and 10, we're going to put on the blanks. So it's now x plus 3 times x plus 10. Step 4 says, just to check our answer, we're going to multiply these two binomials. So x times x will give me x squared. X times 10 will be 10x. 3 times x is 3x. 3 times 10 is 30. In the middle terms, the 10x and the 3x, we can combine them. And the final answer is x squared plus 13x plus 30. And we can see that the product here is the same with our original trinomial on top. So what does it mean? It only means our answer here is correct. And this is our final answer. Let us have example 2. Factor x squared minus 11x plus 24. Step 1. Let us write the factors as two binomials with first terms x. So x plus blank multiplied by x plus a blank. Step 2. Let us now find the two numbers m and n. We are looking for the factors of 24, and here are the factors. 1 and 24, negative 1 and negative 24, 2 and 12, negative 2 and negative 12, 3 and 8, negative 3 and negative 8, 4 and 6, negative 4 and negative 6. And then on this column, we are going to add the factors. 1 plus 24 is 25. Negative 1 plus negative 24 is negative 25. 2 plus 12 is 14. Negative 2 plus negative 12 is negative 14. 3 plus 8 is 11. Negative 3 plus negative 8 is negative 11. 4 plus 6 is 10. Negative 4 plus negative 6 is negative 10. We can see now that this negative 11 as the sum matches our value of b. So it means to say we're going to use the m and n as the last terms of the factors. That is the step 3. This negative 3 and negative 8 are our m and n respectively. So we're going to put these two values on the blanks. So this is now our binomials. X minus 3 times x minus 8. In step 4, if our answer is correct, by multiplying these two binomials. So we have now x times x is x squared. X times negative 8 is negative 8x. Then negative 3 times x is negative 3x. Then negative 3 times negative 8 is positive 24. And then the middle terms, we can see that they are like terms that we can combine. So we have now the final answer, x squared minus 11x plus 24. And our answer here is the same with our original trinomial on top. It means the x minus 3 times x minus 8, and that is our final answer. Let us have example 3. Factor the trinomial x squared minus 2x minus 35. Step 1. Write the factors as two binomials with first terms x. So here it is, x plus blank times x plus blank. And then let us find two numbers, m and n. So we're going to find the factors of this negative 35. So the factors of negative 35 are on this column. First pair is 1 times negative 35. Second is negative 1 times 35. Third, 5 times negative 7. Fourth, negative 5 times 7. On this column, we're going to add the factors. 1 plus negative 35 is negative 34. Negative 1 plus 35 is 34. 5 plus negative 7 is negative 2. Negative 5 plus 7 equals 2. But we're looking for a sum that is equal to the b, and here it is, the negative 2. It means to say, we're going to the step 3 to use the m and n, these two terms here, this pair of factors, to be placed on the blanks. So here it is now, we have the x plus 5 times x minus 7. So step 4, we will check our answer if correct by multiplying these two factors. And we will hope that the answer will be same with our trinomial here. So multiplying the x and the x, that is x squared, x times negative 7 is negative 7x. Then 5 times x is positive 5x. 5 times negative 7 is negative 35. So we're going to combine the two terms in the middle, the negative 7x and the 5x. We will have a negative 2x. So our final answer here is x squared minus 2x minus 35. And we can see that the answer here is the same with our original trinomial on top. It means to say the binomials x plus 5 times x minus 7 are correct and considered to be our final answer. Let us have example 4. Let us factor x squared minus 6x plus 10. Step 1, I'm going to put here the x plus blank and then times x plus blank. Step 2, let us find two numbers m and n, the factors of 10, such that later on we will add them to get a value of b. So on this column, the factors of 10 are 1 and 10, negative 1 and negative 10, 2 and 5, negative 2 and negative 5. In this column, we're going to add each pair of factors. 1 plus 10 is 11. Negative 1 plus negative 10 is negative 11. 2 plus 5 is 7. Negative 2 plus negative 5 equals negative 7. As we can see here, there are no pair of factors of 10 to get a sum of negative 6. In this case, we will say that this trinomial is non-factorable, and this will be our answer here. Let us put some notes here. We know that we are factoring a trinomial that is equal to two binomials, and that is x plus m times x plus n. If c is positive, the c our trinomial, it means to say the m and n The m and n are here, should have the same sign. It can be both positive or both negative. Look at our previous examples 1 and 2. In example 1, the constant is 30 and positive. So look at our factors here. The 3 and 10 are both positive. Also, the sign of the B will tell us that the signs of the m and n should be both positive. Let's have example 2. The constant is positive 24. So look at our m and n. They have the same signs and both negative. Considering the sign of the B here, since it is negative, it gives us idea that these two binomials in the m and n should have both negative also. Now, if C is negative, the m and n should have different signs. Look at our example 3. Our constant here is negative 35. The values of m and n have different signs. One is positive, the other is negative. And there is another clause here. The bigger number between m and n should have same sign with B. So the numbers 5 and 7 is bigger, and because the sign of the B is negative, the 7 as the bigger number will have the negative sign also. I hope you learned something from this video. See you again next time. Today we're going to study division of rational expressions. Let us have the formal definition of division of rational expressions. If P, Q, R, and S are polynomials, where Q not equal to 0, R not equal to 0, and S not equal to 0, then the rational expression P over Q divided by another rational expression R over S is equal to P over Q times S over R. In words, to divide rational expressions, multiply the first fraction by the reciprocal of the second. And the final answer is, we multiply the numerator by numerator, becomes PS. We multiply denominator by denominator, and the answer is QR. How to divide rational expressions, and we're going to follow these 4 steps. Step 1, we write the division as the product of the first rational expression and the reciprocal of the second. Step 2, factor the numerators and denominators completely. Step 3, multiply the numerators and denominators together. Step 4, simplify by cancelling out common factors. Let's have example 1. Divide the rational expressions. Our first rational expression in the numerator is x cubed minus y cubed. all over the denominator is 2x squared plus 2xy plus 2y squared divided by another rational expression. The numerator is x squared minus y squared all over the denominator 4. Step 1 says we are going to rewrite our problem into multiplication of the first rational expression and the reciprocal of the second. So it means the first rational expression we will just copy down here, and then we will change the division into multiplication symbol, and then we take the reciprocal of the second rational expression. Look at the denominator 4. It becomes the numerator down here, while the numerator here becomes the denominator here. And step 2, we will factor the numerators and denominators completely. Our numerator in the first rational expression, x cubed minus y cubed, this is the difference of two cubes, so the factors are x minus y times the trinomial x squared plus xy plus y squared. If you are not familiar with the factors of these two cubes, please check again our video about factoring of two cubes. In the denominator, there is a greatest common factor of 2, so we move the common factor out. So what remains in the trinomial is now x squared plus xy plus y squared. For the second rational expression, the number 4, we can write it to be 2 times 2 over the denominator x squared minus y squared. This is difference of two perfect squares, and the factors are now x plus y and x minus y. For step 3 and step 4, we can combine them, and we can now proceed with the cancellation of common factors. Look at the x minus y here. We can cancel this with the x minus y down here. The trinomial x squared plus xy plus y squared, there is corresponding factor down here also, so we can now cancel both. The number 2 here can now cancel with the number 2 in the numerator of the second rational expression. We can now collect the remaining factors after cancelling respective common factors. In the numerator, it's only number 2 that remains, so we will copy that down here. In the denominator, the binomial x plus y remains, so we will just copy it here. So our final answer is 2 over the x plus y. Let's have example 2. Divide the rational expressions v minus 5 over 11 minus v divided by v squared minus 25 over v minus 11. So I wrote all the steps here. So I will apply step 1 to write again this problem, but I will change the division into multiplication and take the reciprocal of the second rational expression. So it's now here v minus 5 over 11 minus v times the v minus 11 over the v squared minus 25. And step 2, I will factor out the numerators and denominators completely. Our first rational expression, the numerator and denominator is already simplified, so we will just copy it down here. While the second rational expression, let's begin with our denominator. The v squared minus 25 is now factored out into v plus 5 times v minus 5. In the numerator, the v minus 11, we can write this as the negative of 11 minus v. We put it this way so that later we can cancel this with the 11 minus v in the denominator here. So we will now go to step 3 and the step 4. We will combine them. We will now cancel common factors. The v minus 5 can be cancelled with the v minus 5 here. The 11 minus b, we will now cancel with the 11 minus b. And when we collect the remaining terms, take note, there is a negative sign there. So we will put here minus 1 over the remaining factor in the denominator is the v plus 5. So our final answer is the negative 1 over v plus 5. Let us have example 3. We have a rational expression x squared plus 3x minus 10 all over 4x divided by a polynomial 2x squared plus 20x plus 50. The steps are here to guide me. I will begin with step 1. I will rewrite this again as the product of the first rational expression and the reciprocal of the second. So our problem now becomes the first rational expression and then times. Number 1 is now the numerator all over this polynomial. So the 2x squared plus 20x plus 50 is now in the denominator. I will go to step 2 to factor the numerators and denominators completely. The numerator x squared plus 3x minus 10 becomes the product of x plus 5 times x minus 2. And then I will just copy the 4x down here. In the second rational expression, the number 1 is there in the numerator all over. The trinomial here, there is a greatest common factor of 2. We put it outside. What remains in the first term will be x squared. In the second term will be 10x. In the third term is 25. But I can see here that this x squared plus 10x plus 25 can still be factored out. So I'll do another line to copy everything and to put the factors of this trinomial into x plus 5 times x plus 5. And then I will now go to step 3 and step 4 to cancel common factors. The x plus 5, I will now cancel this with another x plus 5 here. And no other common factors that we can cancel. Let us now collect the remaining factors. In the numerator, the x minus 2 times 1, we will have the x minus 2. In the denominator, we multiply 4 times 2 becomes 8. And the x will just copy here. Also, there is the binomial x plus 5. We'll just put it down here. So our final answer is this x minus 2 over 8x times the binomial x plus 5. Example 4. Simplify first rational expression 10 plus w all over w minus 8 divided by the second rational expression 100 minus w squared all over 8 minus w. Let us invert the divisor, meaning the second fraction, and proceed to multiplication. That means the first rational expression we copy down here, times we invert this fraction. So the 8 minus w now in numerator all over 100 minus w squared. We factor out the numerators and denominators completely, and let's do cancellation if possible. In the first rational expression, it is already simplified, so we just copy as is. This 8 minus w, we want to show that this is equal to the w minus 8, but we should write like this: the negative of the quantity w minus 8 all over, we factor out 100 minus w squared. Factors are 10 minus w times 10 plus w. Now, let's do cancellation. We cancel this w minus 8, also the w minus 8. Take note, there is a negative sign outside here. Also, we cancel the 10 plus w and 10 plus w. Then we collect the remaining terms. So we have negative of 1 all over 10 minus w. This is the final answer. In some books, they simplify this further into 1 over w minus 10. That means the negative sign here is put in effect in the denominator. Example 5. Find the quotient 2y squared minus 10yz minus 48z squared all over 2y minus 1 divided by the polynomial 4y squared minus 32yz. Let's invert the divisor or the second fraction and proceed to multiplication. We can see that the value here is a polynomial, but we can show that this is a fraction, showing that the denominator is 1. So in the next step, we do like this. We copy the first rational expression multiplied by the number 1 comes in the numerator all over this 4y squared minus 32yz. Now we factor out the numerators and denominators completely and do cancellation whenever it's possible. First, in the numerator here, a common factor is the constant 2. So 2 comes out times the quantity y squared minus 5yz minus 24z squared all over same denominator will come times the numerator is 1. In the denominator, common factor is 4y times the quantity y minus 8z. We can simplify this trinomial inside the grouping symbol, and the factors are y minus 8z times y plus 3z. And then we copy the remaining values in the denominator and in this second rational expression. Now, let's do cancellation. We can cancel this y minus 8z. There is y minus 8z here. Also, we cancel the constant 2 with a constant 4. The constant 2 becomes 1 and this 4 becomes 2. Now, let's collect the remaining values. So we have in the numerator y plus 3z all over 2 times y is 2y times the binomial 2y minus 1. Example 6. Divide the first rational expression x cubed plus y cubed all over 2x squared plus 2xy plus 2y squared divided by the second rational expression x squared minus y squared all over 4. We invert the divisor or this second fraction and proceed to multiplication. First, we copy the first rational expression multiplied by Now we invert this fraction. 4 comes now in the numerator divided by x squared minus y squared. We factor out the numerators and denominators completely, and let's do cancellation later. The factors for x cubed plus y cubed are x plus y times x squared minus xy plus y squared. In the denominator, we can factor out the common value, which is 2. So 2 comes out times the quantity x squared plus xy plus y squared. Times, we copy the constant 4 all over the factors of x squared minus y squared. And factors are x minus y times x plus y. Now we do cancellation. We can cancel the x plus y and the x plus y here. Also, the 4 and the 2. 2 becomes 1, 4 becomes 2. Note that this trinomial cannot be cancelled out with a trinomial in the denominator because the sign of the middle term are not equal. So, we just put together the remaining values. In the numerator, we have 2 times this trinomial all over the x minus y times this trinomial here. Actually, this can be the final answer. But take note, in the denominator, we have this binomial multiply this trinomial. Notice that these are factors of a special product. When we simplify the denominator, it will be x cubed minus y cubed. Then we copy the same numerator. This is now the final answer.